guys. On our next stop of the scientific method, we have the experiment. So far, we've gone over developing a question and then doing some research based on that question, and then finally developing a hypothesis that we think is going to be the answer to that question. Now, in order to test to see if that hypothesis is correct, we need to develop an experiment. And so I want you to think about this quote first. If you fail to prepare, then prepare to fail. And I want you to pause the video for a second and write down what you think that sentence means. So I think obviously that sentence just simply means that if you don't prepare, then the experiment isn't going to go well. So if you don't set up your experiment the right way, then it's not going to go very well. And so I want to take this situation, this example down here where we're talking about Mr. Tobin. And in this one, Mr. Tobin has a problem in which he needs to fertilize some trees. So Mr. Tobin's long wanted to be a farmer. He bought some land in Africa and is attempting to grow his favorite trees called the baobab trees. Okay, now Mr. Tobin is failing miserably. He needs your help, and he wants you to help him come up with an experiment that would let him or help him decide what kind of fertilizer, if any, he should use to grow the tallest trees. And so we're looking at different percentages of nitrogen. And if you don't know anything about fertilizer and nitrogens, typically the higher the fertilizer, the better the growth. But there's a level there in which, sometimes it can be too much fertilizer. So Mr. Tobin wants our help in figuring out how much fertilizer, how much nitrogen he should use. Okay, and so we are going to take a look at potentially what materials he should use and then the type of procedure that he should come up with. So for materials, what we're looking at here is maybe doing, let's make it a little bit smaller font, maybe doing something like, okay, well obviously we need trees, we need fertilizer, and that's going to come in the 5%, the 10%, the 15%, and the 20%, as those were the types that Mr. Tobin was interested in. Let's just double check. Yes, up to 20% right down here. So Mr. Tobin was interested in these ones. So if we're going to conduct this experiment, these are the materials that we are going to need to use. We also probably need something to measure it. So we'll just be non-specific here. We can call it a measuring tool. We're probably going to need some soil. We're probably going to need some area to plant this. Okay, and you could go on and on and on and on and come up with these different materials. All right. Now, just as important, and probably the most important part of developing an experiment is developing a good procedure. And so for this procedure, we need to go step by step exactly what you're going to do in order to conduct this experiment. So the very first thing that we're going to maybe say on here is, we can skip the stuff about getting all the materials. We don't need to say that. We assume that when we're ready to conduct this experiment that we have all the materials that we require. So we're going to jump right in and say something along the lines of plant 5 trees in each plot. And then the next one can be each plot contains 0% nitrogen, 5% nitrogen, 10% nitrogen, 15% nitrogen, and 20% nitrogen, because that gives us the full coverage of area that we want, or that Mr. Tobin wants to investigate. He said 5%, 10%, 15%, and 20%, but he also said, if any. So in addition to that, Mr. Tobin is also interested in, do we even need to look at any form of fertilizer here? So that's why we're testing out this 0% nitrogen. Okay, now let's continue. Now after we develop how many trees are in each plot and how much fertilizer in each plot, we're going to start to go through we're going to measure the growth every day for 3 months. Just because. Okay, just because we want to see which tree is going to grow the tallest. Okay, and then we can say something along the lines of record this information and develop a answer to the question. Okay, pretty simple. Now, along with developing a procedure to test it, and this is a pretty solid procedure that's going to allow us to test this, we need to also look at the variables. Okay, and I know that you guys have seen this stuff before, but this is super challenging, and so I want to go over it again with the difference between independent, dependent, and constant variables. And so we have this little table that we're going to fill in. The independent variable is the factor within the experiment that changes. So asking yourself, what is the scientist changing? And in this case, what are we changing in Mr. Tobin's experiment? We're changing the amount of fertilizer. Pretty simple. Now, the dependent variable is the factor within the experiment that is affected by the change. So what's going to be affected by the fact that we're changing the fertilizer? We need to ask ourselves, okay, ask yourself, what is being measured or is being affected by the independent variable? And that is the growth or the height of the trees. That's what we're going to be measuring. Now, some of the things that are going to remain the same. These are our constants. Okay, these things are the ones that stay the same for the 0%, the 5%, the 10%, the 15%, and the 20%. And we're just going to go soil, water, the amount of sun those plants get, growth time. Okay, and again, you can come up with a bunch for these, but these are the things that stay the same. Now, in addition to Mr. Tobin's experiment, there's a couple more examples that I want to go over in which we're just going to practice our variables, okay? Just the variables. So we have a situation where we want to figure out what type of sunglasses blocks the most sun. Well, for our independent variable, again, we're looking at, this is the factor within the experiment that changes. What is the scientist changing? Well, in this case, what is it that we are changing? Well, it says which type of sunglasses blocks the most sun, and so the thing that we're changing is the type of sunglasses. Now the dependent variable, let's go back. It says the factor within the experiment that will be affected by the change, what is being measured or being affected by the independent variable. What are we hoping that's being affected by the type of sunglasses? Well, that's the amount of sun that's being let through. Now, if we were going to conduct this experiment, the things that we were going to want to remain the same is probably maybe the person that's wearing them. Maybe the amount of, maybe the sun in the sky that day. Maybe we want to do the time of day be the same. Okay, again, things that we can come up with a million of these, but these are the things that are going to remain the same throughout this experiment. And finally, if we take another situation, we want to know what temperature of water would enable the largemouth bass to produce the most eggs during reproduction. And I give you some options here. It's 16 degrees Celsius, 18 degrees Celsius, 20 degrees Celsius, or 22 degrees Celsius. And the thing here, guys, is we don't have to know the answer. We just have to be able to set up an experiment. And so with the independent variable, remember that question that we want to know is, I'm going to write it right up here, just above it, is what is changing? Well, what are we changing in this experiment? But we're changing the temperature, right? We want to know what temperature of water allows a largemouth bass to produce the most eggs. So the independent variable, or what's being changed, is the temperature of water. Now, what's being measured? What is being affected by the independent variable? And in this case, it's the amount of eggs, because the amount of eggs is dependent on the temperature of water. And again, for constants, things that are going to remain the same. If we were setting up this experiment, these are the things that are going to stay constant the whole time. And in this case, we could do things like the salinity, or how much salt is in the water. We could do things like amount of time in the water. We could do the amount of fish in the water, so that, just keeping things always the same. Okay, so guys, that was quick. That was a lot, but I want to recap real quickly with you, okay? Just to go over some things again. With the materials, we're making a list of things that we're going to use throughout the experiment. With the procedure, it's a step-by-step set of instructions. And, I think for this, being as detailed as you can is better, and making sure that you're not leaving out any sort of information that could be needed. Okay? With the variables, we've got the independent, and I want you to ask yourself, what is the scientist changing? With the dependent, I want you to ask yourself, what is being measured or what is being affected by the independent variable? And then the constants are real simple in the fact that these things are the things that stay the same the entire time. Okay? Now, guys, we're going to practice this, and so I don't want you to worry about this. This is going to be something that we spend some time on and practice and make sure that we understand. So if you need more help, go back and watch this again, or come and see me and let's make sure that we understand this.